Dear student, today I will discuss about advanced encryption standard AEC. Now, the previous lecture we discussed about the data encryption standard. So, advanced data encryption standard is the advanced version of DES. So, general introduction about the advanced encryption standard cipher. It is designed by Rizman Deman in Belgium, or AES is designed by number of bit has 128 oblique 192 and 256 bit keys. So 128 bit data and iterative rather than faster cycle. These bit data process in form of data block of 4 column and 4 byte. Operation on entire data block in every round. So designed to be for this AES main purpose, resistant against the known attack, speed and code compactness on many CPU, and design simplicity. This is the objective and the advantage of the AES. So advanced encryption standard is designed and provide the privacy security more than with respect to data encryption standard, because number of keys has used in AES like that 128 oblique 192 oblique 256 bit. So AES is a non-fastidious cipher that encrypt and decrypt a data block of 128 bit. It uses 10, 12 or 14 round according to the key size, which can be 10 round for 128 bits data, 192 for 12 rounds, and 14 round for 25th bit, depend on the number of rounds. If number of rounds 10, then we use number of keys 128. If AES number of round encryption decryption equal to 12, then number of keys size equal to 192. If number of round is uses 14, so we use the encryption key size equal to 256. AES has defined three versions with 10, 12, and 14 rounds. Each version uses different cipher key size like 128, 192, and 256, but the round keys are always 128 bits. It is the very important point, because AES has defined three versions with the 10, 12, and 14 rounds. Each version uses a different cipher keys size. Each version uses different cipher key size. 10 for 180, 128, 12 for 192, and 14 for 256. But the round key are always 128. So general design of advanced encryption standard cipher like that. If 128-bit plain text insert into encryption for AES, so first is pre-round transformation, and in this pre-round transformation, key K0 whose size 128 bit, K0 has size 128 bits, round keys are encrypted. After encryption of pre-round transformation, produce output is work as an input in round 1, and in round 1 encrypted this input data with the help of key K1. Now round 1 encrypted data produce output. This output of around 1 is work as an input of round 2 and it is encrypted by EK2 and so on. This is process is performed round NR. Now NR is the depend number of last round is slightly different above round. We will discuss uh, in next topic. So round NR, if 10, the key size is 128, key size apply cipher keys 128. If round NR key number of round equal to 12, then apply the cipher key size equal to 192 and round key size is fixed 128. If round key is to 256 bit, then we apply for round 40. Relationship between number of round and cipher key size is given in this way. And after last round NR, then produce the 128-bit cipher text. Now, so the AES encryption process like that. The plain text is divided into the block. It means total number of block is 16 bytes. Each byte is contain 8 bit, so 16 multiplied by 8 and total number of block is divided into 16 bytes. So input array are stored in form of 16 byte 4 by 4 column, and in this input size we apply the initial transformation with the help of round 0 key, and round 0 key is also stored in 4 bytes 4 by 4 matrix array. After performing the input state, after performing the transformation state after initial transfer, we produces 16 byte array data and it input in round 1 for transformation. Then we apply round 1 key 16 byte. After applying the key, round 1 encrypted and produce the matrix, and these matrix, process matrix are stored in the state matrix. Is stored in state matrix. And round 1 state matrix produced after the transformation, it work as an input of round 2 and round 2 encrypt and store in state array. So the process continue the round n minus 1. After round n minus 1, the last round is slightly different from above round because above all rounds 0 to n minus 1 perform 4 transformation, while in last round perform only 3 transformation. So it is slightly different from above round 0 to n minus 1. Now final state produced by round n, and these final state are stored in the 4 byte array as a cipher text. Here number of round and relation of round and key is given. Relation is like 10 equal to and 12 equal to and 14 equal to. For 10 rounds, key byte equal to 16, for 12 equal to 24 and 14 equal to 30. So Advanced encryption standard structure is like that: data block, a 4 column, a 4 byte is state. Key is expanded to array of words. So has 9, 11, and 13 round in which state is undergoes. So 9, 0 to 9, 0 to 11, 0 to 13 rounds परफॉर्म हो रहे हैं. स्टेट जो हो रहे हैं उसमें ये सेवरल ऑपरेशन जो परफॉर्म होते हैं लाइक दैट. बाइट सब्स्टिट्यूशन means 1s box used on every byte. every byte के लिए 1s box यूज कर रहे हैं. शिफ्ट रोज, परम्यूट बाइट्स बिटवीन ग्रुप्स एंड कॉलम. अप्लाई द शिफ्ट रो कर रहे हैं. परम्यूटेड बाइट्स को ग्रुप और कॉलम में शिफ्टिंग प्रोवाइड कर रहे हैं. मिक्स कॉलम, सब यूजिंग मैट्रिक्स मल्टीप्लाई ग्रुप्स यूज करके मिक्स कॉलम कर रहे हैं. ऐड राउंड की के साथ ऐड राउंड करके एक्सऑर स्टेट विद की मटेरियल के साथ एक्सऑर ऑपरेशन परफॉर्म कर रहे हैं. व्यू द ऑल्टरिंग ऑफ एक्सऑर की स्क्रैम्बल डेटा बाइट्स. So initial XOR key material and incomplete last round with fast XOR and table lookup implements. So AES structure like that. If plain text apply in the initial round, we add the round keys, and each round key use the key size 0 to 3 in the 4 transformation. Key is expanded in forward. After add round, the output input as a round 1 and round 1 perform have 4 type of operation like substitution byte, shift rows, mix column, add round key. And each key is equal to divided into 4 group W03, W4, 4 to 7, 8 to 11, 12 to 15, like that. Now, this round add round is 0 to 3, and this add round is W. Dash. Several operations are performed, round 9 and round 10. So, in the round 9, use add round key W36 to 39, and last round 10 is contain only 3 transformations: substitution byte, shift row, mix column are not performed in the last round. Then apply the add round key. In the add round key, we use the key word W40, 43, and reverse operation apply the for the decryption, then find the plain text. This is the simple advanced encryption structure of the AES. So data unit used in AES like that. If B byte are stored in the array, 1 byte stored in the array B0, B1, 2, B7 is form of column B0 to B7 byte. Any word W stored B0, B1, B2, B3 words and transform in a column. Block are performed like that. B0 say 15 are divided into 4 blocks: B0 to B3, B4 to B7, B8 to B11, B12 to B15. So these input are stored in intermediary state like that. The first word stored in state array diagram, state array like that: S00, S10, S20, S30. Any W0 word are stored in this column. and W1 word are stored in this column, W2 word is stored in this column, W3 stored in the column. So after state transform, state array produce the word like that W0, W1, W2, W3. So block to state and state to block transformation like that. Suppose block to state we use SI mod 4 comma I by 4. Any block of I is indicate S of I mod 4 comma I by 4 means Si mod 4 comma I by 4. A block means this block I 0. So 0 comma 0 B0 B1 block I P1 I1 comma 4 0 is 1 comma 0 2 2 by 4 0 3 by 0. So S comma 0 B0 store state matrix are stored in this way. A block of I. Block of I means block of value, block value of block equal to 0. For block of 1 mod 4, 1 mod 4, 2 mod 4, 3 mod 4, 4 mod. So block diagram are stored like that. First B0, B1, B2, B3 and next started from B4, B5, B6, B7, next B8, B9, B10, B11, B12 to 50. S00 are stored in B0, S10 state store value the B1 and S20 stored value B2, S30 stored value B3. Means Si mod 4 I by 4. I by 4 divided the value 4 element by 1 by 4. So no fractions, apply the 0 state. This is applied for 0 word. W1, W0 state store in this. W2 store this, W1 store this, W2 store this, and W3 store this. Similarly, state to block transformation like that, Sij converted into block like block I plus 4j. Sij, suppose S00. S00 means block I value 0, 4 into 0, block equal to 0, store block B0. S10 means I value 1, J value 0, I value 1 plus J0, store in P1. Similarly, S20 means I value 2, J value 0, S2 and B2. Similarly, B3. Now value for S01 means I value 0, J value 1. So value of B4. So value for S11, I value 1, 4 into J1 equal to B5. This is state to block transformation. Now again we explain for back block to state and state to block transformation in this way. Suppose I value denoted this. So suppose block value I equal to 0. We put 0 mod 0, 0 by 4, S00 for B0. If value of B1, I value 1. So B1 equal to 1 mod 4, 1 and 1 by 4 equal to 1 by 4 equal to fraction, the lower bound equal to 0. Similarly, we can write for I equal to 4, 4 mod 4, 0, 4 by 4, 1, इसलिए S01 equal to 4. This is the back block to state transformation, and similar way the state to block transformation denoted in this. Now example, for changing plain text to state. How? Suppose that text is given AES USE SMMATRIXZZ. So first we converted the given text into hexadecimal form. A we can write 00, E equal to 04, S equal to 12, equal to 14, S equal to 12. After conversion of this, the value stored 0004, 12, 14, and 12, 44, 4, 12, 00 in this way. This is the changing place text into the state. So the AES structure of each round, the encryption site like that, state is 4 by 4 matrix, 4 by 4 matrix, and each subbyte, perform each subbyte in state of addition of key. Next we perform the shift rules in given state, and after find out the shift rule output of shift rules, we apply the mixed column of this input state. After applying the mixed column, we find the output of this state, and we apply the add key round like that round key, and then find the plain text of AES like that. So in the next lecture we discuss these intermediary operation of the advanced encryption standard.